Imagine lying beneath a clear night sky, the kind where the air feels still and the stars look close enough to touch. Somewhere out there, in that deep silence between constellations, something small and ancient is moving, not toward you, not away, just passing through. It doesn't belong to our sun or any of its planets. It's a wanderer from another place entirely. Astronomers call it Three-Eye Atlas, and even the name sounds like a secret whispered across space. When the first faint light from it reached Earth, most people didn't notice. A few observatories caught a streak in their automated sky surveys, just another speck sliding across the dark. But when scientists looked closer, they realized this one didn't behave like the usual comets. Its path, its speed, its tilt. Everything about it hinted that it came from somewhere far beyond. And so begins the quiet story of a traveler that had been adrift for millions, maybe billions of years, wandering through the galaxy before our world ever had oceans or trees. It moved through interstellar darkness, past the dust of dead stars and the slow light of newborn ones, carrying within it the chemistry of another system entirely. And somehow, through coincidence or cosmic rhythm, it found its way here, a guest from another sun. You might think of a comet as a glowing, roaring object with a long tail sweeping across the sky. Three-Eye Atlas wasn't like that. It was modest, almost shy, visible only to telescopes that scan the heavens each night for moving dots of light. One of those telescopes was the Asteroid Terrestrial Impact Last Alert System, or ATLAS for short. It keeps watch for anything that might one day come too close to Earth. On the night of July 1st, 2025, it spotted something faint and fast. The team led by Darrell Seligman noticed that this particular speck was moving quicker than expected. Far too quick. When they ran the numbers, the math told them something startling. This object wasn't just orbiting the sun, it was escaping it. That single realization changed everything. To move that fast, 58 kilometers per second, means it had to come from interstellar space. No ordinary comet inside our solar system travels at such speed. It was the third interstellar object ever discovered after Oumuamua and Borisov, and instantly every telescope that could move began turning to catch a glimpse before it was gone. You can almost imagine the quiet excitement in observatories across the world. Computers whirring, domes sliding open under pre-dawn skies, scientists staring at screens filled with faint streaks of light. Each exposure captured not just an image, but a moment of connection between our small world and the wide unknown. The Canada-France-Hawaii telescope confirmed what Seligman's team had guessed, that Three-Eye Atlas came from beyond. Then the Very Large Telescope joined in, and the data became undeniable. The orbit wasn't closed. It was hyperbolic, the unmistakable signature of a visitor that would never return. There was something poetic in that number, 175 degrees. That was the inclination of its path compared to the plane of the planets. It meant the comet's approach was almost a mirror image of the way Earth and its neighbors circle the Sun. 5 degrees off from our own orbital tilt, as if the universe had aimed it deliberately along our path, just close enough to be seen. Of all the infinite directions it could have come from, it chose the one that let us notice. When astronomers compared it to the first two interstellar objects, they realized how different it was. Oumuamua, discovered in 2017, had been tiny, maybe 400 meters long, and oddly shaped, like a flattened cylinder, tumbling end over end. Borisov, seen in 2019, had been larger, nearly a kilometer across and far more comet-like. But Three-Eye Atlas was in another category altogether, between 5 and 10 kilometers wide, a miniature world. If you close your eyes, you can almost picture it, a dark, irregular sphere drifting through starlight, its surface coated with ices older than the sun. Every crack on it holds chemical secrets from a star that burned out long before ours was born. And now that piece of that other world is here, coasting through our solar system before vanishing again into the void. Even the light it reflected was unusual. Observations from the 10.4-meter telescope in the Canary Islands revealed that it was redder than most comets, resembling a D-type asteroid, the sort that live far beyond Mars, near Jupiter's orbit or in the cold fringes beyond. Its rotation period, measured precisely, was about 79 hours with to one slow turn each cosmic day. That steady spin kept its face to the sunlight just long enough to warm the ice beneath. In those first weeks after discovery, scientists began digging through archival data, hunting for any earlier glimpses. They found them, dozens of them. The Vera Rubin Observatory, still in testing mode at the time, had unknowingly captured 37 separate images of 3I Atlas as it crossed the sky. It was like finding old photographs of a friend you hadn't yet met. Another surprise came from NASA's TESS mission, the satellite designed to look for exoplanets by measuring starlight dips. For nearly a month, from May 7th to June the 2nd, TESS had been staring at the same region of sky the comet happened to cross. Buried in its continuous data stream were the subtle brightening and dimming patterns that revealed just how large the object might be. Around 4 kilometers across. Even back in May, months before anyone officially discovered it, it had already begun to show faint signs of activity. A coma, the hazy envelope that forms when a comet's ices begin to sublimate in sunlight. If you imagine that moment, the feeling is oddly comforting. Light from our sun touching something that's never known it before, coaxing a thin mist of gas and dust from its frozen surface. The solar system welcoming a stranger in the only language it knows, warmth. Every major telescope wanted its own look. The Palomar 200-inch, Gemini South, Grand Canary, NASA's Infrared Telescope Facility, and the 3 8-meter UCERT all joined the watch. Each collected a few photons, each added another brushstroke to the portrait. The Gemini South team, led by Bin Yang, caught it early, between July 5th and 14th, and measured its color precisely. Dark, red-brown, low in reflectivity, like volcanic rock coated in soot. The spectrum reminded them of the Tagish Lake meteorite, a rare carbon-rich stone that once fell over Canada. That connection hinted that 3I Atlas carried similar materials, organic compounds, complex carbons, the raw chemistry of life, forged in some other cradle of creation. When the Hubble Space Telescope finally turned its gaze toward the traveler on August 4th, the image it captured was ghostly. From 3.8 astronomical units away, Hubble saw a bright core wrapped in a faint cloud, the coma. Scientists estimated that the comet was shedding 12 to 120 kilograms of material every second, a slow, graceful exhale of ancient ice turning into vapor. But what stunned them most was the anti-tail, a narrow streak of dust pointing toward the sun instead of away. Normally, a comet's tail is pushed outward by solar wind, streaming behind it like hair in the breeze. But here, the geometry was different. The material on the sunlit side was lifting off gently and drifting inward, defying expectation. It wasn't magic, just orbital perspective and timing, but it looked almost deliberate, as if the comet was reaching back toward the light that was warming it. The deeper the astronomers looked, the stranger it became. The James Webb Space Telescope, using its infrared eyes, found that the gas surrounding 3I Atlas was rich in carbon dioxide, with a ratio of 7:6 compared to water vapor, the highest such ratio ever recorded. That single measurement opened an entire chapter of speculation. Why so much carbon dioxide? One idea was that cosmic radiation in interstellar space had baked the comet's surface over billions of years, preserving CO2 while other ices evaporated away. Another possibility was even more thrilling. That 3I Atlas formed in its home system near the carbon dioxide frost line, a region so cold and distant from its parent star that even CO2 stayed frozen solid. Our own solar system has a similar pattern, a water ice line near the asteroid belt, where warmth fades enough for vapor to freeze and farther out still, a line where carbon dioxide itself turns to ice. If 3I Atlas originated at that far boundary around another star, it meant we were looking at a physical sample from an environment utterly unlike our own, a piece of another world's deep cold. When you think about that, it's hard not to feel small in a comforting way. The universe isn't empty, it's connected. One system's leftovers become another's visitors. The same atoms drift through stars, planets, comets, and living beings, cycling endlessly through time. Even in the most exacting data, there was poetry hiding between the numbers. Every observation told a story, telescopes opening like eyes, light arriving after journeys longer than civilization itself, scientists leaning closer to their monitors in quiet awe. There was no noise, no explosions, no spectacle, just a whisper of reflected sunlight carrying across light years. And as the weeks passed, the comet grew brighter. Not by much, just enough for observers to feel its presence more deeply, like a shy guest who, once noticed, begins to share more of its story. In those moments, Earth itself seemed to listen. When astronomers looked at 3I Atlas through the James Webb Space Telescope that August, the first thing they noticed was how alive the data felt, even though what they were seeing was frozen beyond imagining. Light that had left the sun almost an hour earlier was now bouncing off a traveler older than any world in our solar system. It was like reading a postcard from another sun, written in chemistry instead of words. The spectra, long, thin rainbows of data, told them something rare and unexpected. Instead of the familiar balance of water vapor and carbon dioxide found in most comets from our neighborhood, 3I Atlas had 7 times more carbon dioxide than water. That ratio wasn't just a quirk. It was a fingerprint. It told scientists this object didn't form anywhere near our sun. To understand why, you have to picture how comets are born. Around every young star is a disk of dust and gas, a nursery of worlds waiting to form. Close to the star, it's too warm for most ices to exist. Water and carbon dioxide vaporize, leaving only rocky minerals. Farther out, the light fades, temperatures drop, and new boundaries appear. Invisible lines called frost lines, where different gases freeze solid. Our own solar system's water frost line sits roughly between Mars and Jupiter, a region now filled with asteroids. Beyond that lies the carbon dioxide frost line, where even CO2, which needs extreme cold, can condense into ice. Out there, worlds like Pluto form from frozen gas and rock, drifting in perpetual twilight. But 3I Atlas's signature told another story, one where carbon dioxide wasn't just present, it dominated. That could mean the comet was born at or beyond the CO2 frost line of another star, orbiting so far from its parent sun that its surface never saw warmth. Over billions of years, gravity and time could have nudged it loose, sending it drifting into the interstellar dark, where it wandered until it found us. That's what made this comet so special. It wasn't just passing through our sky, it was bringing the weather report of another solar system. Even now, if you picture it, the small body gliding through space, its dark surface slowly releasing ancient gases into the vacuum, you can almost feel how delicate the process is. Nothing rushes, nothing burns. The ices sublimate one molecule at a time, each one catching a little sunlight before fading into invisibility. It's like listening to time breathe. From those faint emissions, astronomers could tell what 3I Atlas was made of, the same way a musician might know a song by hearing only its echo. And in that echo were clues that stretched across the history of the galaxy. The Gemini South Telescope picked up traces of nickel in the comet's coma, the glowing halo of gas surrounding it, but curiously, no iron. That was strange. Normally both metals are released together from dust grains heated by sunlight. Yet here, nickel appeared alone, shining faintly in spectrographs, as if iron had never been part of the mix. This detail puzzled researchers. Nickel doesn't sublimate easily. It needs far more heat, than the comet was experiencing at that distance from the Sun. The explanation they settled on was gentle but fascinating. The nickel wasn't melting out directly. It was likely locked inside organic molecules, carbon-based compounds that were evaporating at lower temperatures. As those organics broke apart, they freed the nickel atoms, which then floated into the surrounding coma like metallic ghosts. And floating alongside them was another familiar molecule, cyanide. That word might sound sharp, harsh even. But in space, cyanide is ordinary. It's a building block of prebiotic chemistry found in comets, nebulae, and even the clouds around young stars. Over a century ago, when scientists first detected cyanide in Halley's comet, people on Earth panicked, fearing its tail might poison the air. It didn't, of course. But the myth survived, a reminder of how easily wonder turns to worry when we don't yet understand. Here, in the soft darkness of space, cyanide is just another note in the cosmic song, a molecule that connects one comet to another, one system to the next. 3i Atlas carried it too, whispering of chemistry universal and familiar, even across billions of miles. For months, observatories kept watching. On September 4th, the Gemini South Observatory captured images of the comet's emerging tail. Faint, just a 20th of a degree across the sky, visible only in the largest telescopes. It wasn't the long, dramatic sweep people imagine when they think of comets. It was thin, almost hesitant, like a painter's first brushstroke. But there it was, the signature of motion, the quiet confirmation that sunlight was gently unmaking the traveler. By then, astronomers had gathered enough information to reconstruct its path with remarkable precision. They realized 3i Atlas came from far above the plane of the galaxy, from a region known as the thick disk, a population of old, metal-poor stars that formed early in the Milky Way's history. That made the comet ancient even by cosmic standards. According to calculations led by Matthew Hopkins, it was likely 6 billion years old, older than our Sun, older than Earth itself. Imagine that, an object that had already traveled through space for billions of years before our planet even existed, now passing by just close enough for us to study it for a few short months. It's hard to describe how that realization feels. The numbers are almost too large to think about. But when you put them into perspective, when you let your mind slow down enough to grasp them, it becomes something else entirely. It's not just data. It's perspective. A reminder that our moment in time is small, but beautifully so. Astronomers weren't finished tracing its story. Another study by Exbiscuto and colleagues tried to reconstruct 3i Atlas's stellar encounters, the times when it might have passed near other stars before arriving here. They ran simulations across 10 million years of motion, identifying 93 encounters with other stars. The closest one was about 0, 3 light-years away, a glancing brush that changed its velocity by only half a meter per second, barely a nudge in the cosmic scale. From those gentle numbers came a profound truth. This comet's journey was stable, patient, uninterrupted. It hadn't been flung violently from system to system. It had simply drifted, following gravity's soft handwriting across the galaxy for eons. That quiet persistence is part of what made scientists fall in love with it. There's something soothing about the way the universe moves when you strip away the noise, how even chaos over enough time becomes rhythm. As 3i Atlas continued its inward path, it began to cross the orbits of the inner planets. On October 3rd, it came within 19 astronomical units of Mars, about 28 million kilometers. That's not close in everyday terms, but in the language of interstellar visitors, it was intimate. For the first time, a comet from another star passed near a world that humanity had touched. Mars was silent as it watched. Orbiters and rovers turned their cameras skyward. The Perseverance rover took long, 30-second exposures of the night sky, capturing faint blurs of motion. Scientists stacked those images to reveal the subtle glow of 3i Atlas, the first time a Martian machine had photographed a comet from another sun. The ExoMars mission joined in, making its own short exposure images between October 1st and 7th, recording a soft blur moving slowly across the background of stars. Even the Mars Express orbiter tried, though its sensors weren't sensitive enough to capture much detail. Still, the attempt mattered. Every camera that turned upward became part of the story. That's one of the quiet beauties of astronomy. Even when data falls short, the act of looking still holds meaning. After Mars, the comet would continue its glide toward the Sun, passing near Venus, Earth, and later Jupiter. Not close enough for danger, but close enough for us to watch. Telescopes from ground and space kept tracking it as long as they could. But by late autumn, 3i Atlas slipped behind the Sun from Earth's view, hidden by glare, unreachable for a while. The universe doesn't pause for us. It moves at its own unhurried pace, always onward. And so astronomers waited. They ran models, planned observations, and looked forward to when the comet would reappear from behind the Sun's bright disk. In those months of waiting, there was something peaceful about knowing it was still out there, unseen but continuing its ancient route. Steady, faithful, unbothered. For those who study the stars, there's comfort in that kind of patience. You can't rush a comet. You can't demand it show you its secrets faster than it wants to. You wait, you observe, you learn, and you let the silence between discoveries be part of the story. Back on Earth, data continued to arrive from missions in other parts of the solar system. The JUICE spacecraft, preparing for its observations near Jupiter, and the ongoing analysis of Hubble and Webb's earlier captures. Scientists combed through the numbers with the same gentle care a watchmaker might give to an heirloom. Each measurement of brightness, each chemical ratio was another clue, another fragment of a tale that began long before humanity existed. And in the middle of it all, one question still hung quietly in the background. The same one that always arises when something strange and beautiful appears in our sky. Could it be artificial? That question would come later, wrapped in speculation and debate. But for now, as 3i Atlas moved through sunlight and shadow, the simplest truth was enough. Something born around another star had wandered here, letting us see the shape of its long, patient story before vanishing again into the dark. When 3i Atlas disappeared behind the Sun, there was a strange kind of pause in the astronomy community, a collective holding of breath. For months, the object had filled telescopes with whispers of color and motion, tiny shifts in brightness that spoke of deep cosmic history. And then, just like that, it was gone from view, hidden by the Sun's glare. In that gap, when data stopped flowing and silence took its place, imagination began to drift in. It always happens this way. When something from beyond arrives, the mind searches for stories big enough to match its scale. For some, that means poetry and awe. For others, it means suspicion, the quiet question. What if it isn't just a rock? That question had echoed once before, years earlier, with another interstellar visitor, Oumuamua, the first of its kind ever found. It too had come fast and quiet, tumbling through the solar system on a hyperbolic arc before vanishing into darkness. It had reflected sunlight in odd ways, accelerated slightly in ways no one fully understood, and for a time, some wondered, could it have been a vessel, a relic, a machine built by minds not our own? Now the pattern repeated. A new visitor, new anomalies, and a world once again suspended between skepticism and wonder. At the heart of that new debate was Avi Loeb, a Harvard astrophysicist known for his bold ideas. In papers and interviews, he proposed that 3i Atlas too might be more than natural, that perhaps it was an artifact, a piece of technology crossing the galaxy. To him, its speed, its chemistry, even its angle of approach held the potential fingerprints of design. Most scientists disagreed, but not angrily. They understood curiosity is what drew them all to the stars in the first place. But they also understood how easily wonder can leap ahead of evidence. So they slowed down, examined, measured, compared. Loeb's claim wasn't without structure. He pointed to 9 anomalies, observations that, in his view, didn't fit the usual cometary models. Some were about its size, 5 to 10 kilometers, far larger than typical interstellar fragments. Others involved its chemistry, the high carbon dioxide ratio, the presence of nickel without iron, and its curious alignment close to the ecliptic plane of the planets. 5 of those anomalies, he believed, could not yet be explained. He wasn't claiming certainty. He was claiming curiosity. And in science, curiosity is both the spark and the risk. It opens doors, but it also tempts us to see patterns that might not be there. To those following the story, the discussion was mesmerizing. It was never a loud argument, more like a slow conversation under the stars. People asked not, is it aliens? But what would we accept as proof if it were? And that question, quiet and philosophical, became the center of late-night talks in observatories and living rooms alike. Another researcher, James Davenport, and his team published a paper in response, laying out what true evidence would need to look like. If 3-eye atlas were something artificial, there would have to be measurable physical differences, not just speculation. 4 key criteria, he said, could separate science from imagination. The first, trajectory. If the object changed its path in a way that couldn't be explained by sublimating gases or gravitational nudges, if it slowed down or turned against the laws of orbital motion, then something was guiding it. The second, spectrum. A comet's reflected light carries its chemical fingerprint. If that light ever showed signs of metals, alloys, or synthetic materials, if it shimmered in a way no natural surface could, then we would have reason to look closer. The third shape. Most natural bodies are irregular or roughly spherical. But if it had a consistent geometry, a triangle, a disk, a long, narrow rod, that might speak of intention rather than accident. And the fourth, transmission. If any radio signal, even faint, repeated in a non-random pattern coming from its direction, the conversation would change completely. But 3-eye atlas showed none of those signs. Its orbit followed gravity perfectly. Its spectrum matched natural chemistry. Its light curves suggested a rounded, uneven shape, not mechanical precision. And every radio telescope that pointed toward it found only silence, the vast, natural silence of deep space. In that silence, scientists found peace. Because even without mystery, the truth was extraordinary enough. A fragment of another solar system, older than Earth, had wandered into our backyard. That alone was almost too much wonder for one generation. Still, the thought lingered like starlight after dusk. Not the belief that it was artificial, but the hope that maybe one day we might find something that truly is. The universe is vast, and every visitor feels like a message, even if the message simply says, "You are not alone in wondering." And while YouTube channels and blogs spun their stories, some wild, some thoughtful, the astronomers stayed patient. They kept to their work, letting the data speak. One by one, the anomalies began to make sense. The inclination near the ecliptic? Coincidence, a natural outcome of detection bias. We tend to spot objects that pass through the plane where most telescopes focus, near the sun's path across the sky. The unusual chemical ratios? Evidence of a birthplace colder than ours, not of construction. The high speed? Exactly what you'd expect from something falling through the galaxy's gravitational web. Science didn't need magic. The real explanation was gentle and astonishing in its own right. Every number refined, every theory tested, every line of code adjusted in orbital simulations. All of it brought the picture into clearer focus. And the clearer it became, the more beautiful it looked, because understanding doesn't erase wonder, it deepens it. When astronomers spoke about it, their words were never dry. You could hear the affection in their voices, the quiet awe at being alive at the right moment to witness a visitor from another sun. Some even said, half in jest, that if aliens ever did send something, they could hardly choose a better disguise. A comet is the perfect messenger, ancient, anonymous, and unstoppable. But jokes aside, everyone knew the truth. Sometimes reality doesn't need imagination's help. It's already poetic enough. And yet there's something to be said for those wild ideas. They remind us that curiosity is a kind of kindness, an unwillingness to stop asking questions, even when the answers seem impossible. The universe doesn't punish wonder, it invites it. So while the academic papers rolled in, cautious, careful, filled with equations and uncertainties, the dreamers kept dreaming. And in their dreams, 3I Atlas wasn't just a rock of ice. It was a message from deep time, proof that we are part of a galaxy that still surprises itself. The world didn't fall asleep that year because of a theory. It fell asleep thinking about one. And that, in its own way, made the night sky feel more alive. Back in observatories under the slow rotation of domes, scientists waited for the comet to re-emerge from behind the sun. They knew that when it did, its brightness would fade again, its tail thinning as it moved outward. But they didn't mind. Every stage of its passing had something to teach, something gentle. For many of them, the waiting was as beautiful as the discovery. Because astronomy is a discipline built on patience, a willingness to sit quietly and let the universe reveal itself, one small photon at a time. And so the whispers of theory softened into quiet acceptance. The alien debate faded, replaced by something humbler, calmer. The recognition that what we had seen was already miracle enough. 3I Atlas wasn't a machine. It wasn't a signal. It was something older, deeper, and infinitely more patient. A traveler from a time before memory, crossing paths with a species still learning to listen. And somewhere, beyond the glow of our star, it kept moving. Not to send a message, but to exist. And that, in the end, might be all the message we ever need. When the sun swallowed the comet from sight, there was a hush across the telescopic world, a moment of quiet in which even the machines seemed to rest. 3I Atlas had slipped behind the blazing glare, unreachable, its faint reflection drowned in radiance. For months, astronomers could only imagine where it was. They followed its projected orbit in simulations, watching digital dots glide across dark screens, their trajectories traced by mathematics and patience. The numbers were clear. Soon it would emerge again, thinner, dimmer, but still there, still moving. On Earth, summer had turned to autumn. Observatories shifted to other projects, yet in every data log, in every notebook, one question lingered softly. When it returns to view, what will it have become? The story of comets is the story of transformation. Each one carries within it the seeds of its own unmaking. As sunlight warms its surface, frozen gases awaken, turning to vapor that escapes into space. Dust follows, forming tails of light that stretch for millions of kilometers. To watch a comet brighten and fade is to watch time unfold, ancient ice becoming breath, then memory. 3I Atlas was no exception, though it behaved with a kind of restraint. Even as it approached its closest point to the sun, its activity was gentle, almost serene. On October 29, 2025, it reached 136 astronomical units from the sun just beyond Earth's orbit, a respectful distance for such an ancient traveler. At that moment, sunlight washed across its nucleus, illuminating a world of contrasts. Craters carved by cosmic dust, smooth plains of frozen carbon dioxide, pockets of darker material rich in complex organics. Each patch glimmered differently, turning the comet into a slow-spinning mosaic. In that brightness, telescopes caught it again, faint but steady. The Hubble Space Telescope, now aging but tireless, opened its instruments once more. From its vantage above Earth's atmosphere, it recorded the shimmer of the coma, measuring how sunlight scattered through the outflowing gases. Even across millions of kilometers, that reflected light carried information about the comet's heartbeat, the rhythm of its spin, the rate of its fading. The James Webb Space Telescope followed soon after, peering through infrared wavelengths to read the comet's warmth. What it found was a glow so faint it was almost philosophical, a temperature just above absolute zero, yet alive with motion. In those wavelengths, 3I Atlas looked like a small ember adrift in the dark, burning not with fire, but with persistence. Meanwhile, in the cold of Mars' orbit, the ExoMars spacecraft continued sending back its earlier frames, images taken during the comet's October flyby. The data arrived slowly like letters from another time. Scientists stitched the exposures together into a silent animation, the comet gliding through the Martian sky, stars sliding past in the background. No music, no narration, just motion, measured and calm. It's strange how emotion creeps into numbers. The data was pure, mathematical, yet when people saw it, they felt something ancient stir. The same feeling early astronomers must have felt when they first charted the wandering stars. Wonder is the universe's oldest language. By November, 3I Atlas had curved around the Sun and begun its outward journey. For Earthbound observers, it would take weeks more before the comet emerged from the glare, but for spacecraft stationed farther out, the show continued uninterrupted. The JUICE mission, the European Space Agency's probe heading toward it, Jupiter's moons, happened to be on the far side of the Sun relative to Earth. Its instruments were perfectly placed to glimpse the comet as it brightened at perihelion. Engineers adjusted the spacecraft's cameras, hoping to capture faint images or perhaps even pass through the outskirts of the comet's tail. In a paper published later by Marshall Eubanks and collaborators, they predicted that JUICE might fly directly through the outer traces of the comet's dust stream in early November. No one expected fireworks. The density of the material was far too low to cause any danger. But the idea of a human-made machine brushing past the breath of an interstellar traveler carried quiet poetry. Farther back in the solar system, NASA's Juno spacecraft orbiting Jupiter waited for its own brief chance to see the comet months later, when it would pass 36 astronomical units from the giant planet. That encounter would be distant. No dramatic visuals, just subtle measurements of reflected light. But even those small readings would stretch humanity's presence into places we could not yet go ourselves. Every mission, every observation felt like part of a larger unspoken collaboration, a cosmic relay, each handoff of information forming a bridge between worlds. By late December, Earth's observatories could finally see 3I Atlas again. It appeared weaker now, its coma thinning as it drifted away from the sun's warmth. The once prominent tail had faded to a faint blur, detectable only through long exposures. Yet the excitement had not diminished. There's beauty in departure too, in the knowledge that something extraordinary came close enough for us to witness before continuing on its endless path. Astronomers compiled months of data into charts and light curves, mapping every flicker of brightness against distance. The patterns told them the comet's surface was changing, its outer layers shedding, revealing fresh ice beneath. Each rotation released new jets of vapor, creating subtle variations in brightness. And beneath all that quiet analysis, one truth kept echoing. 3I Atlas was unlike anything we'd seen before, and yet it obeyed the same universal rules. Its strangeness wasn't alien. It was natural, born of conditions foreign to us, but common somewhere else. That realization softened even the fiercest debates. The universe, it turned out, didn't need to be mysterious to be miraculous. Meanwhile, astronomers revisited one last curiosity, the comet's anti-tail, that thin sunward plume of dust first seen months earlier. Follow-up studies revealed that the feature persisted longer than expected. Models suggested it formed not just from solar heating, but from the comet's own slow rotation, releasing material in periodic gusts that curved gently toward the light. It was as if the comet, turning endlessly through space, had learned to wave in sunlight. By early 2026, 3i Atlas was on its way outward, climbing above the plane of the planets, retracing the long curve that would eventually free it from the sun's gravity altogether. Its speed remained astonishing, nearly 58 kilometers per second relative to the sun, fast enough that no planet, no star, could capture it again. Soon, it would cross Jupiter's orbit, then Saturn's, and beyond that the edge of our solar influence, the boundary of the heliosphere, where solar wind fades into the quiet sea between stars. From there, it would continue for millions of years, maybe billions, until gravity from another system caught it, or until collisions and cosmic dust slowly eroded it into nothing. But even nothing isn't really an ending. In space, all things continue in new forms, molecules spreading, atoms joining new worlds. 3i Atlas would never truly disappear. It would just change address. Back on Earth, scientists began to publish their final round of analyses. The data from Hubble, Webb, JUICE, and the ground-based telescopes formed a mosaic of understanding: chemistry, dynamics, temperature, motion, each piece fitting neatly into the others. The big picture was elegant and serene. An interstellar comet formed in a carbon dioxide-rich region around another star, billions of years ago, that had wandered undisturbed through space until chance brought it near us. No alien technology, no miracle, just the quiet majesty of physics unfolding exactly as it should. Yet even with so much explained, the sense of mystery didn't vanish. If anything, it deepened. Because now scientists weren't just looking at one object. They were looking ahead. If 3i Atlas existed, then there must be more. Dozens, maybe hundreds, drifting unseen between the stars, crossing our solar system every century, each one carrying the fingerprints of its birthplace, and soon they would not pass unnoticed. New observatories like the Vera Rubin telescope, with its wide-field cameras scanning the heavens every night, promised to detect many more interstellar visitors in the coming decade. Some would be smaller, fainter. Others might surprise us again with new compositions. Each one would be another page in the growing story of the galaxy's shared debris, proof that the universe, in its vastness, still allows its worlds to meet. When people hear that, they often smile. Not because they expect aliens, but because it feels comforting. Space isn't empty. It's alive with exchange. We are not isolated. Even now, as you listen to this story, invisible particles from ancient stars are falling softly through the air, resting on your skin. You carry the universe within you the same way 3i Atlas carried traces of another sun. And as the comet faded once more into the dark, the scientists who'd followed it from its first discovery knew they'd been witnesses to something more than discovery. They'd seen connection, the way knowledge itself moves through space and time, handed from telescope to telescope, from one curious mind to another. Every observation, every image was a conversation across centuries of starlight, and 3i Atlas, silent and steadfast, continued that conversation long after it vanished from our sight. There's a certain silence that follows a discovery once the noise fades. The comet had passed, the images had been taken, the data logged and shared. The telescopes turned to other targets, the researchers wrote their papers, and the world, for a time, stopped speaking about 3i Atlas. But the silence it left behind wasn't empty. It was the kind that lingers when something vast has brushed against your understanding and your mind is still catching up. Even now, years later, those who worked on it talk about the experience the way sailors speak of rare weather. Quietly, reverently. They remember the nights of waiting, the long hours watching faint light curves crawl across their monitors. They remember how it felt to realize that for a few brief months they were in communication with something older than the sun. That's what 3i Atlas gave us. Not just data, but perspective. When you think about it, the odds of such an encounter are almost impossible. Our solar system is a moving island drifting through a sea of stars. The distances between them are so enormous that even at 58 kilometers per second, it would take this comet tens of thousands of years to cross from one star's sphere of influence to another. And yet somehow, in the middle of all that emptiness, paths crossed. It's humbling, because if something that ancient and small could find its way here, then maybe connection, cosmic or human, isn't as rare as it feels. In the months after its closest approach, scientists began to publish their reflections. The numbers, the graphs, the chemical ratios, all of it was beautiful in its precision. But in between the technical lines, you could sense a softer emotion, the unspoken awe that seeps in when you realize you've just watched history from another world pass through your own. They wrote about the carbon dioxide frost line, about nickel without iron, about the stable hyperbolic trajectory that told them this object had never been part of our solar family. But hidden between those observations was something more human, the understanding that the galaxy is not a place of isolation, but of slow, constant exchange. Dust from one sun becomes the seed of another. Atoms forged in one explosion drift for billions of years before settling into new homes. A rock, a planet, a living body. You are breathing those same atoms now. The iron in your blood, the calcium in your bones, the carbon in your breath. All of it came from stars. 3i Atlas reminded us of that in the most tangible way possible. It was the universe's quiet way of saying, "You're made of me too." Somewhere in its icy layers are the same molecules that exist inside us. Cyanides, carbons, complex organics. The ingredients of biology that form spontaneously whenever chemistry has enough time and peace to work.
That means, in a sense, this comet wasn't alien at all.
It was familiar, family from a distant branch of the same cosmic tree. The more scientists studied it, the more they realized that the galaxy itself seems to prefer repetition. The same elements, the same patterns, the same cycles appear everywhere. In nebulae, in stars, in planets, in comets. 3i Atlas was another verse in that long, repeating song. And yet, no two verses are exactly alike. The ratio of carbon dioxide to water was new. The texture of its tail, the density of its coma, the subtle spin of its nucleus are all unique. Each interstellar object carries its own accent, its own dialect of creation. By studying them, we begin to learn not just about one world, but about the grammar of worlds themselves. That realization changed how astronomers think about planetary systems. Before 3i Atlas, we imagined our solar system as a self-contained story, born, evolved, destined to fade in solitude. Now we know it's part of a conversation much larger and older than we'd guessed. Comets like this one are the messengers, crossing light years to deliver news of how other stars live and die. They are, in a sense, cosmic diplomats, uninvited but always welcome. The Comet Interceptor mission, planned by the European Space Agency for 2029, was inspired in part by these encounters. Instead of chasing a known target, it will wait in deep space, patient and ready. When the next interstellar visitor arrives, it will fire its thrusters and meet it mid-journey, sending back close-up images and samples before the comet disappears again. For now, the idea feels ambitious, but that's how science grows, not through certainty, but through patient curiosity. The same kind that guided Galileo's first telescopes, that built Hubble, that turned James Webb's golden mirrors toward the dark. 3i Atlas reminded us that patience is the real instrument of discovery. And somewhere deep down, there's another truth hiding beneath the equations. One less about physics and more about philosophy. Every comet is temporary. They flare, they fade, and they go. But each one leaves traces. Tiny particles of dust that settle into new orbits. Soft debris that drifts for centuries, caught in the gravity of new worlds. In time, that dust becomes part of something else, a ring, a moon, a seed of another planet. Nothing in space truly vanishes. It only changes form. So when people ask, what happens next for 3i Atlas? The answer is quiet but certain. It continues. It will move beyond Jupiter, past Saturn, Neptune, and Pluto, until the Sun becomes just another point of light behind it. It will cross the outer boundary of the heliosphere into the interstellar medium, where the solar wind fades and the galaxy's breath takes over. Out there, no heat, no light, just the faint hum of cosmic rays and the constant drizzle of dust from dying stars.
That's where it belongs. Not because it's lost, but because it's home everywhere.
And as it drifts, it carries a little of us with it. Not physically, but through the photons that touched it. Sunlight reflected from our star, coded with our spectral signature, now spreading outward into the dark. Each glint of light that bounced off 3i Atlas continues traveling, a faint echo of our existence expanding into forever. Somewhere, centuries from now, maybe another civilization will catch those same photons. They might measure their wavelengths, note the faint red shift, and realize what they're seeing. The reflection of a small yellow star and the worlds around it. And in that moment, we'll have introduced ourselves. Not through radio, not through technology, but through the quiet kindness of light. That's the gift comets give us. They remind us that communication doesn't always require intent. Sometimes just existing in motion is enough. Astronomers often speak of perspective as their most precious tool, not just in distance or scale, but in meaning. When you study the cosmos long enough, the boundaries between observer and observed start to blur. You realize that when you gaze into the universe, you're not just looking outward, you're looking backward, inward, through layers of time and matter that include your own beginnings. 3i Atlas became part of that mirror. In its frozen layers, we glimpsed the story of another sun, not ours, but kindred. In its passage through our sky, we glimpsed our own fragility, how temporary, how beautiful, how improbable it is to exist at all. And maybe that's why its story feels so restful now, because in the end, the universe didn't send us a warning or a riddle. It sent us a reminder that everything drifts, everything connects, and nothing is truly apart. So as scientists filed their final reports and the world moved on to newer discoveries, 3i Atlas continued on its way. A dot fading into darkness, steady, patient, eternal. And maybe tonight, if you step outside and look up, you won't see it.
You'll just see the same calm sky, the same stars.
But somewhere beyond what your eyes can reach, that traveler is still gliding, carrying with it a little of our sunlight, a little of our attention, and a little of the quiet wonder we sent after it. And perhaps that's enough. To know that somewhere out there, something remembers that we once looked up. There comes a point, far beyond the orbits of the outer planets, where the sun's influence begins to fade.
Not suddenly, but gradually, like the way warmth fades as you walk away from a campfire.
The light still reaches, but the touch grows weaker, and the wind, that constant solar breath, begins to lose its voice. That place is called the heliopause, the border between our solar system and everything else. It's not a line you can see, but a transition. The moment where particles streaming from our sun slow, stop, and meet the ancient wind of the galaxy itself. And that's where 3i Atlas is headed now. Even as it moves, its speed remains astonishing, nearly 58 kilometers per second, enough to cover the distance between Earth and the Moon in under 2 hours. But here, speed doesn't feel fast. There's no up or down, no sense of motion. Just stillness, and eternal, soft, endless. The sun behind it has shrunk to a bright white star, smaller than Venus looked in its days near Earth. Around it, the vast emptiness is not truly empty. Thin clouds of hydrogen and helium drift through space, along with cosmic rays and magnetic ripples from long-dead stars. This is the interstellar medium, the thin ocean between islands of light, and 3i Atlas drifts through it like a leaf through calm water. The heat that once stirred its ices has vanished. Its surface, now fully frozen, is locked at a temperature just a few degrees above absolute zero. The vapor that once streamed off its surface has dissipated, leaving behind a dark, inert shell. The faint coma, that halo of life it once wore, has dissolved into the void. What remains is pure stillness, of an ancient world asleep at last. But even sleep in space has motion. Tiny collision, invisible atoms striking its surface, send faint vibrations through its structure. The comet doesn't feel them, of course.
It doesn't feel anything.
Yet those impacts add up over centuries, gently polishing the ice, reshaping the dust, whispering to it that the journey continues. The stars out here seem sharper, almost electric. Without the haze of solar dust, light travels cleanly. Every point of light has a story. Some are red dwarfs burning steadily for trillions of years. Others are blue giants living fast, burning bright, destined to die young. Somewhere among them might be the star that birthed 3I Atlas, the one whose gravity first shaped it, whose warmth never quite reached it. Astronomers have tried to find that birthplace. They've traced its orbit backward through millions of years of galactic motion, adjusting for the tug of nearby stars and the shifting arms of the Milky Way. The results are uncertain. Too many variables, too much time. But the models suggest it came from the thick disk of the galaxy, a region filled with older, metal-poor stars, suns that formed when the Milky Way was young. That would make 3I Atlas almost twice as old as our own Sun, about 7 to 10 billion years in age. Just imagine that. A piece of matter that's been drifting since before Earth existed, before even our star began to shine, still here now, still moving, still obeying the same gentle laws that govern everything. You can almost feel the stillness of it if you breathe slow enough, that sense of motion, too large to see, too ancient to rush. And somewhere, far behind, humanity continues its own small journey. The Voyager 1 and Voyager 2 spacecraft, launched decades ago, are still moving outward too, slowly, their signals now faint whispers received by giant dishes on Earth. They, too, have crossed the heliopause into the same ocean 3I Atlas now drifts through. But even they move slower, less than 17 kilometers per second. The comet is long past them, gliding farther and faster, outpacing even the best of our creations. In that sense, 3I Atlas is ahead of us, both literally and metaphorically. It carries the kind of patience we have not yet learned. Every so often, cosmic rays strike its surface, knocking loose atoms of carbon or oxygen, slowly changing its color. It darkens, then lightens, then darkens again, a slow cycle without rhythm, painting time itself across its crust. If you could somehow stand on its surface, not that you could, but imagine, you'd see nothing but stars, motionless and infinite. You'd hear nothing, not even your own heartbeat, because sound cannot travel there. You'd see the sun as a small white bead lost among millions of others, and you'd realize that everything you've ever known, every sunrise, every voice, every home, is contained within that one pale dot. That thought alone is enough to make even the most restless mind grow quiet. 3I Atlas will pass near other stars eventually, not soon, not in any time that matters to us, but someday. Astronomers estimate that in 2 million years it will come within a few light years of another star, perhaps stirring again under new light. Maybe it will warm, crack, release new gases. Maybe it will remain unchanged, gliding on as it always has.
It doesn't matter.
The universe isn't in a hurry. Even now we continue to study it from afar. Radio telescopes occasionally sweep the region of sky where it should be, not expecting to hear it, but to measure the background, the faint radio glow of space dust that once reflected off its tail. The data they collect helps refine our maps of interstellar radiation, helps us understand how the galaxy itself breathes. In that way, the comet still teaches us, even in silence. It's easy to think of it as alone out there, but in truth, it's part of a vast migration. Countless other fragments, asteroids and icy bodies drifting between stars. Some will pass close to suns and flare with light.
Others will wander unseen forever.
Together they form an invisible network of travelers, connecting worlds that will never meet. That's the quiet secret of interstellar space. It's not empty. It's shared. The same dust that once glowed in 3I Atlas's tail will eventually mingle with grains from other comets, with particles from supernovae, with the ashes of old planets. Over millions of years, gravity will weave them into new systems, new suns, new beginnings. One day those atoms might become another world, maybe with oceans, maybe with air, maybe even with someone standing on its surface looking up, wondering if they are alone. And if they could see far enough, perhaps they'd catch the faintest glimmer of something ancient passing through their sky. A small object reflecting light from their star. They might point telescopes toward it, measure its motion, debate its nature. They might give it a name, write papers, whisper theories. And maybe, just maybe, they'd find traces of carbon dioxide and water in its spectra. And they'd wonder, could it have come from that yellow star, the one we now call the sun? And just like that, the story would begin again. Another visitor, another chance to connect. That's the beauty of space. Endings don't exist, only continuations. Every discovery is both a farewell and a promise. So, as 3I Atlas drifts deeper into the dark, beyond the last reach of sunlight, it doesn't fade. It joins the rhythm of everything that has ever moved through this galaxy, a rhythm so slow, so vast, that even eternity feels like a gentle hum. And somewhere, back here on Earth, someone still remembers it, a comet that came and went quietly, teaching us that the unknown isn't something to fear. It's something to listen to. The universe has no walls.
It only has distance.
And distance, given time, is just another word for connection. So the traveler continues, silent, small, eternal, carrying the light of our sun into the dark that made us. When the comet slipped beyond the reach of our telescopes, the observatories didn't fall silent all at once. For a while, astronomers kept turning their mirrors toward the patch of sky where 3I Atlas had been, the way someone keeps looking at the place where a friend once stood. The data streams came slower, the signals weaker, until there was only background noise, a steady cosmic hush that sounded a little like breathing. Still, that hush carried meaning. It told scientists that their instruments were working, that the universe itself was still whispering. The absence of 3I Atlas became another kind of presence, a reminder that the things we study sometimes leave before we're ready, and that learning often begins after the subject has gone. Across the world, papers continued to publish. Teams compared spectra, refined velocity models, debated the chemistry of its coma. They built new software to simulate the object's flight, rewriting code deep into the night, fueled by coffee and wonder. But outside those glowing screens, the world had moved into winter. Students trudged through snow to late classes on exoplanet dynamics. Professors drew diagrams of hyperbolic paths that curved off the whiteboards and into imagination. And everywhere, beneath those quiet calculations, lived a sense of awe that was oddly tender. Because 3I Atlas had reminded everyone of something simple and enormous, that our solar system isn't sealed. The stars don't stay where they're born, and neither do their fragments.
Space is porous, alive with motion.
Each passing object is a letter delivered across billions of years, and this one just happened to drift into our mailbox. For months, news sites and YouTube channels, perhaps even this sleepy one, replayed the timeline. They spoke softly of Darrell Seligman's discovery, of the Atlas telescope's nightly watch over the sky. They mentioned how, on that July night in 2025, the algorithms flagged a dot moving a little too fast, a little too straight, and how that small anomaly became a story that circled the globe. Listeners loved the part about speed, 58 kilometers per second. It sounded like something out of a dream, swift enough to leave the sun's gravity behind, gentle enough to drift without ever stopping. People imagined it streaking past the outer planets, past the faint rings of Neptune, past Voyager 2's tired antenna. They closed their eyes and pictured the trail of red dust, glowing faintly like a heartbeat in the dark. Back on Earth, those images did more than inspire bedtime wonder. They nudged technology forward. Engineers at ESA and NASA met to discuss what an interstellar interceptor might require. Thrusters, cryogenic shields, the patience of decades. The proposed Comet Interceptor mission planned for 2029 gained new urgency. If the universe was going to keep sending visitors, we had to be ready to greet them properly. At first, these meetings sounded technical, full of acronyms and trajectory math. But underneath the equations ran something more human. Hope.
Hope that next time when another traveler crossed our sky, we wouldn't just watch from afar.
We'd meet it halfway. In university dorms, astronomy students began to name their projects Atlas's heir or interstellar cousin. They coded little simulations showing what a rendezvous could look like. Tiny ships drifting beside a frozen wanderer, exchanging nothing but light. Some professors smiled at the optimism. Others quietly saved the animations because they remembered when science felt that fresh. Meanwhile, ordinary listeners, the ones who had heard the story in podcasts or sleepy videos, found comfort in the idea that something so small could cross so much space. For insomniacs, it became a metaphor for endurance. For dreamers, a proof that the unknown can arrive without warning, carrying beauty instead of fear. The bedtime tone worked because it mirrored the comet itself. Calm on the surface, full of quiet momentum underneath. There was another effect too, subtler but lasting. When astronomers analyzed the comet's composition, its strange ratio of carbon dioxide to water, its lack of iron, the faint traces of nickel, they realized it didn't match anything born near our sun. That meant its chemistry came from a place with different rules, maybe even a different kind of sunlight. For planetary scientists, this was revolutionary. If one small rock could show such variation, then every interstellar visitor might rewrite our textbooks. If our own solar system formed with a water frost line, another could form with a carbon dioxide frost line. And that meant the universe wasn't standardized, it was experimental. The more they looked, the more questions appeared. Could there be whole systems where carbon dioxide snow-built worlds, where oceans were made of something we'd call impossible? Could life, or something like it, arise in such chemistry?
No one knew.
But the questions themselves carried a rhythm that soothed even the most analytical minds. It was the rhythm of curiosity, slow and eternal, like waves on a cosmic shore. At planetariums, new shows began to appear. Visitors from beyond, messengers between stars, the Atlas Path. Families reclined in dark domes while narrators spoke in voices meant to lull as much as to inform. They projected three-eye Atlas across ceilings, an amber-red speck crossing the Milky Way, leaving a faint contrail of possibility. Children fell asleep under those domes, and somewhere in their half-dreaming thoughts, science and wonder fused into one. Even in scientific circles, something similar happened. Normally, when a paper is published, it sparks debate, sometimes rivalry. But this time, most of the papers about Three-Eye Atlas began with shared gratitude, to telescopes, to colleagues, to the sheer luck of seeing it at all. Maybe that's what an interstellar visitor does. It softens the edges between us for a moment. And while the comet drifted farther into darkness, the data it left behind became brighter. The James Webb Space Telescope's carbon dioxide readings continued to echo through conferences. Every time researchers displayed that 7:6-to-1 ratio, audiences leaned in, sensing that they were glimpsing a fingerprint from another sun. Somewhere between the rows of equations and graphs there was poetry too. A carbon dioxide-rich nucleus, one scientist mused aloud, means it formed where even sunlight couldn't melt the frost. Another replied quietly, so it was born in shadow. The room had gone silent for a moment, and someone whispered, maybe that's why it travels so well through darkness. They laughed softly, but no one forgot that line. Meanwhile, social media did what it always does. It filled with theories. Some were creative, some wild. A few insisted again that it was an alien craft. Most scientists dismissed those ideas kindly, explaining orbital mechanics and sublimation. But a handful of educators realized those viral conversations could serve a different purpose. They used them to teach skepticism gently, turning rumor into lesson, anxiety into curiosity. Ask for data, they'd say in live streams, and if you can't find it, imagine how you'd measure it yourself. The approach worked. Viewers who came for the mystery stayed for the science. And late at night, when streams wound down and chat boxes slowed, people wrote things like, "This was oddly relaxing," or "I didn't expect space to make me sleepy in a good way." The storytellers smiled. That was the goal all along, to make knowledge feel like rest, not strain. So the comet, even in absence, continued to shape how we talk about the universe. It reminded people that the cosmos isn't just explosions and equations, it's lullabies written in light. It taught that patience is a form of discovery, and it showed that sometimes the best way to understand something vast is to describe it softly like you would a dream. By the end of 2026, most telescopes had archived their 3i Atlas data. The excitement had faded into routine reference numbers and citations. But every now and then, when a new interstellar candidate flickered across a survey image, someone in the control room would murmur, "Could be another Atlas." The words carried both caution and quiet joy. At home, far from observatories, a few of those same astronomers tucked their children into bed and found themselves telling the story again, not as data, but as bedtime tale. Once a comet came from another star, they'd begin. It traveled faster than anything we'd ever seen. We pointed all our telescopes at it, and it taught us how old the galaxy really is. The children would listen, eyes heavy, and somewhere between curiosity and sleep, they'd learn their first lesson in scale. That, perhaps, is 3i Atlas's most lasting orbit, not through the solar system, but through imagination. Each retelling keeps it circling, softly within us. And when the night grows quiet, when you step outside and look up at a sky that feels both endless and familiar, you might remember that faint red traveler still out there, far beyond Pluto's pale shadow, carrying sunlight into darkness. It doesn't need engines or intention. It just moves, like thought, like time, like the slow rhythm of your own breath as you drift towards sleep. You can let that image settle now, a small sphere gliding through forever, leaving nothing but calm behind. Tomorrow, astronomers will wake and run new models.
Children will dream of rockets.
The comet will keep going.
Everything will continue exactly as it should.
And that thought, the quiet continuity of it all, is enough to make even the restless night feel safe. For weeks after the comet vanished from view, the night skies above observatories around the world seemed a little emptier. Astronomers who had spent every clear night watching its faint glow found themselves gazing out of habit, as though their eyes still expected to find that reddish streak moving between the stars. They knew it was gone, that it had crossed the sun's invisible border and was now beyond the reach of light sensitive enough to catch it. But knowing didn't make it easier to stop looking. There's something quietly human about that, our need to keep watching long after the moment has passed. But that's what interstellar objects do. They remind us that everything moves on. 3i Atlas didn't just bring data, it brought perspective. It reminded us that we live inside something vast and ongoing.
Every orbit, every flicker of light, every grain of dust is part of a conversation that began long before we were here to listen.
Think of it like this. Every comet is a storyteller, carrying memories of its birthplace. Most of them were born with our sun, icy relics from the cloud of gas and dust that collapsed into our solar system billions of years ago. But 3i Atlas was different. It carried someone else's story, written in chemistry we'd never seen before. Its carbon dioxide-rich surface, its slow rotation, its strange red tint, all of these were sentences in a language we'd only just begun to learn. Scientists can measure its orbit and its spectra. They can map its composition, but meaning, the quiet, emotional kind, emerges elsewhere. It appears in the way people talk about it, in the soft tone of documentaries, in bedtime stories that turn astrophysics into whispers of wonder.
There's power in that.
Because when we talk softly about the universe, it starts to feel like home. Imagine, this comet spent billions of years adrift between stars,
Untouched, unseen, and then, for a few brief months, it passed through our skies.
reflected our sunlight, and became part of our collective memory. It didn't need to do anything spectacular. Just existing within view was enough to make thousands of humans look up together. There are very few things that can make people stop scrolling, stop arguing, stop rushing. But a visitor from another star,
That's one of them.
maybe that's why 3i Atlas felt special. It arrived without invitation, without mission, and still managed to unify curiosity across continents. For scientists, it was a challenge, an object to decode. For dreamers, it was proof that the universe itself still surprises us.
And for the quiet listener, maybe for you, it was something even simpler, a reminder that the unknown can be beautiful.
In a way, 3i Atlas became a mirror. When people asked whether it might be an alien craft, what they were really asking was, are we alone in this endless dark? The answer, of course, remains elusive. But perhaps the more interesting truth is that we ask the question at all. That curiosity itself is the sign we're not alone. We are part of a network of minds, of questions, of living patterns searching for understanding. That's what life does, it observes, and that's what 3i Atlas helped us remember. When the James Webb Space Telescope found that unusually high carbon dioxide ratio, 7.5 parts CO2 to 1 part water, scientists debated its meaning for months. Some thought it was a clue to a carbon-rich formation zone far beyond any we've known. Others suggested it meant the comet had been bombarded by cosmic radiation for eons, altering its outer layers. But whichever theory you favored, one thing was clear. This object came from conditions utterly unlike our own. That realization can be strangely comforting. Because if worlds can form in such variety, if chemistry and starlight can combine in countless ways, then the universe isn't cold or empty. It's diverse. It's creative. It's generous in the materials of existence. Maybe somewhere, in a system that once shared this same region of space, there's another civilization looking outward too. Maybe they've detected a comet passing through their neighborhood, a faint, icy traveler that carries traces of our sun's chemistry. Maybe they're wondering about us, the same way we wonder about them. The distances are unfathomable, but thought travels faster than light. And thought, after all, is what connects us. When we watch something like 3i Atlas, we're really watching our own curiosity in motion, a spark that began when the first humans looked up and wondered what those lights in the sky were. That same spark has passed through every generation since, changing shape but never fading. It's there in the astronomer's quiet concentration, in the late-night coder debugging telescope data, in the listener who lets a science story play softly while drifting toward sleep. It's the same light, just traveling through different mediums. There's a quiet kind of irony in how the comet taught us patience. Its speed was unimaginable, but its lesson was slow. Understanding doesn't come from racing after meaning, but from sitting still long enough to see what stays. That's how astronomers found its pre-discovery images, by combing through old archives, patiently layering one image atop another until the faintest motion emerged. That patience is what revealed its existence months before anyone realized what they were looking at. Sometimes progress doesn't mean building faster telescopes or launching bigger rockets. Sometimes it means learning to look more carefully at what we already have. And that too is a kind of lullaby, one that hums in the background of science, reminding us that discovery is as much about stillness as it is about exploration. In that spirit, some researchers began reanalyzing old data from the first 2 interstellar visitors. Oumuamua and Borisov. Each had its own quirks, Oumuamua's cigar-like shape, Borisov's vivid coma. Now with 3i Atlas in the mix, patterns began to appear. Each one showed subtle traces of how different star systems create and eject matter. Each one hinted at the way galaxies recycle material across generations. Even the most pragmatic scientists admitted it felt poetic, as if the galaxy itself was sending us notes, one visitor at a time. The numbers spoke, but so did the silence between them. Perhaps that's the ultimate role of a story like this, to let people rest inside the enormity of it all. The universe is busy, but it doesn't rush. It builds mountains from dust over millennia, weaves new stars from gas that's billions of years old, folds time itself into spirals of light. Within that patience, our brief lives are not meaningless. They are moments of awareness, the universe briefly knowing itself. That idea comforted many who heard the story of 3i Atlas. It didn't matter whether they understood spectral analysis or hyperbolic velocity. What mattered was the feeling, that quiet awe, that release of tension that comes when you realize you're part of something immeasurably larger, yet not excluded from it. Maybe that's why bedtime stories about space work so well. They give the mind something vast to rest upon. They replace the small anxieties of the day with questions too big to worry over. And when those questions are wrapped in real science, in the truth of measurements, observations, and evidence, the comfort deepens, because reality itself becomes beautiful enough to dream about. 3i Atlas, in its quiet passage, gave us that kind of dream. It reminded us that even facts can feel sacred when spoken softly. One of the astronomers who worked on the Gemini South observations said it best during a late-night interview. The reporter had asked, "What was it like, seeing something from another star?" The scientist paused for a long time before answering. "It was like watching the universe take a breath," she said, "and realizing we were breathing with it." That sentence traveled far. People quoted it in articles, posted it online, printed it on posters at science museums. Some even used it as a meditation line. It became one of those quiet phrases that outlives the moment that birthed it. Not because it's profound, but because it feels true. The universe does breathe. In light, in dust, in comets.
In and out.
You can almost feel it now if you slow down enough. The pulse of something bigger than galaxies, running steady beneath all the chaos. That's the space 3i Atlas leaves behind. A space not of absence but of connection. And somewhere, millions of kilometers away, the comet continues, unobserved but unchanged, following the same perfect path carved by gravity and time.
It doesn't know we named it. It doesn't know it taught us.
It simply exists, and that in its own silent way is the purest form of grace. Time in astronomy never really stops. It just changes scale. Months after 3i Atlas disappeared beyond the sun's glare, the research proposals began. They arrived quietly, PDFs sliding through inboxes at midnight, filled with equations, instrument designs, patient optimism. Each one opened with a line that sounded almost like poetry. "Another will come." That was enough. The idea that interstellar visitors were not rare miracles but steady travelers passing through at intervals humanity could witness, that changed everything. Funding committees met in rooms still scented with coffee and marker ink, and for once, the arguments were not about why, but how.
How could we be ready next time?
How fast could a spacecraft react? How could it sleep in orbit, waiting until a new object was spotted racing in from the dark? That's how the Comet Interceptor mission took shape. The engineers spoke softly about it, almost reverently. A spacecraft that would wait at the edge of Earth's gravitational influence, like a fisherman sitting perfectly still on calm water until the next visitor appeared. Then at the right moment, it would wake, burn its engines, and meet the traveler head-on. The design meetings were strangely calm affairs. There was excitement, yes, but also a sense of responsibility. 3i Atlas had shown that the universe sometimes sends us gifts without warning. The least we could do was be ready to receive them properly. Meanwhile, the Vera Rubin Observatory continued its nightly watch. Its wide-field eyes scanned the sky again and again, catching thousands of moving dots each night. Somewhere among them, the next messenger might already be gliding inward. The observatory's team spoke of their work as listening to the dark, and in a way, that's exactly what it was. Back on Earth, public fascination hadn't faded. Planetariums updated their shows, adding segments on future encounters. The idea wasn't to predict, space resists prediction, but to prepare imaginations. Audiences learned what a hyperbolic orbit looked like, how scientists distinguish interstellar velocity from solar-bound motion. They leaned back in padded chairs, eyes half closed, watching simulations of comets moving through fields of stars. For many, those domes became a modern form of meditation. The data was real, but the feeling was something deeper, a collective exhale in the dark. In classrooms, younger scientists traced the legacy of 3I Atlas through equations and inspiration alike. Some focused on the chemistry, planning missions to test volatile ratios in future comets. Others chased the orbital dynamics, refining models of galactic tides and stellar encounters. But all of them, even the most technical, carried a certain softness when they spoke of it. They'd pause before pronouncing its name, as if saying it too loudly might disturb the delicate path it followed. One graduate student at MIT described her dissertation simply, "I'm writing a love letter to motion." Her advisor smiled and didn't correct her.
Because really, that's what astronomy often is.
Even those who weren't scientists found themselves changed in small, steady ways. Amateur stargazers began keeping visitor journals, sketching imagined comets on blank pages, labeling them with dates that hadn't happened yet. Musicians sampled telescope data, turning photon counts into ambient tracks that pulsed like distant heartbeats. Poets wrote about light older than language. It was as if 3I Atlas had brushed against humanity's creative field as it passed, leaving ripples we still feel. And then there were the spacecraft already out there, the Voyagers, the New Horizons probe, the long-sleeping pioneers. Mission controllers sometimes joked, half seriously, that maybe one day one of these emissaries would cross paths with another interstellar object. They imagined silent, glancing encounters somewhere in the dark, two artifacts of curiosity passing each other by. No communication, no collision, just mutual recognition between things built by gravity and things built by thought. Those thoughts made their way into documentaries, podcasts, bedtime channels. They formed a new kind of comfort story, that we are not standing still. Our reach extends farther every year, not through conquest, but through observation. By early 2027, data analysis teams published a collective paper, Comparative Study of Interstellar Small Bodies, Oumuamua,
By Borisov, 3I Atlas. It read like a chronicle of discovery and patience, each object stranger than the last.
each one challenging what we thought comets should be. The closing paragraph was unexpectedly gentle. We are learning to listen across the void. Every object that visits brings not answers, but better questions. That line caught on. Teachers quoted it. It became a quiet mantra in science communities, an antidote to certainty. The more we knew, the more mystery deepened, and somehow that made everyone breathe easier. In an age when information moves too fast, 3I Atlas reminded us that truth unfolds slowly. A comet's trajectory isn't a headline, it's a sentence written across years. You can't rush comprehension any more than you can rush the seasons of the sky.
And so people slowed down just a little.
Observatories reported more volunteers, more late-night visitors standing outside to feel small on purpose. Sleep apps borrowed the story, turning it into guided meditations. Imagine an object from another star, crossing ours like a thought through the mind of the galaxy. The voices were calm, the music low, and countless listeners drifted off before the ending. It turns out science told softly can be a lullaby. That realization reshaped how educators spoke to the public. Outreach became less about dazzling facts and more about tone, about creating a space where wonder could rest instead of rush. The best communicators learned to leave pauses between sentences, the way the universe leaves darkness between stars. In those pauses, listeners found peace. Meanwhile, the debate about the worst theory still flickered in certain corners of the internet. The insistence that 3i Atlas was an alien craft. Most scientists no longer argued against it. They simply explained gently that absence of evidence is not presence of mystery. The fascination with that idea wasn't harmful. It was human. It spoke to our longing for connection, for signs that someone else is out there watching too. And perhaps that longing was part of the comet's gift. Because every serious paper written to counter wild speculation became an opportunity to teach how knowledge works, how evidence is gathered, how humility is built into every equation. Humility is another word for listening. So the legacy of 3i Atlas grew, not in new photographs, but in the tone of scientific conversation itself. Researchers began to phrase conclusions with more tenderness. It appears, it suggests, it may be. Those words carried kindness toward the unknown, an acknowledgement that even the clearest data lives beside mystery. That kindness rippled outward. When students presented their findings, they spoke slower. When audiences listened, they interrupted less. Somewhere between comet tails and conference halls, patience had become fashionable again. And maybe that's what 3i Atlas was always meant to teach, not through deliberate message, but by example. It moved through our system without haste, unaffected by chaos, following a trajectory older than memory. Its calmness became contagious. Even now, years later, if you stand outside on a clear night and look south toward the faint blur of the Milky Way, you might sense that calm. Every star in that band is a sun, every sun surrounded by debris, every fragment a possible traveler. Somewhere another one has already begun its journey inward. When it arrives, someone will notice. Telescopes will turn, software will light up, the story will begin again. But for now, the sky waits. And maybe that's the most peaceful state of all, waiting not with anxiety but with wonder. Because out there, in the distances beyond time's reach, something is always coming our way. Not to scare, not to conquer, but simply to be seen. And we, small and temporary as we are, have learned how to look. So close your eyes for a moment. Picture the vastness overhead, the patient orbits, the silent trajectories, the shared gravity that holds everything in gentle conversation. That's the inheritance 3i Atlas left us, the art of listening to infinity.
Night after night, the sky keeps its rhythm.
Stars rise, fade, return. The planets draw their patient loops. Telescopes blink and whisper. But somewhere beyond every orbit we can name, 3i Atlas keeps going, no longer visible, yet never entirely gone. The astronomers who once tracked it still check their data sometimes. Not because they expect new information, but because the act itself feels like greeting an old friend. The spreadsheets and images are memories now. Frozen photons from a time when that tiny traveler shared our sunlight. Each pixel, each curve on a graph is a photograph of a moment when we looked outward and found ourselves reflected back. That's what the story of 3i Atlas has become, a mirror for our own persistence. Even after the last press release faded, its influence remained quietly stitched into how we think. New students entering astrophysics speak of it as a legend, a reminder that the universe will always send surprises. Some carry small pieces of the comet's color palette, a deep red, almost rust, in digital art, in wallpaper backgrounds, in the hues of new mission logos, tiny tributes to something that asked for nothing. In public observatories, guides still tell its tale to small crowds. The lights dim, the dome opens, and the storyteller begins not with data, but with a tone, low, unhurried, the kind that invites the night itself to lean closer. Once, they say, a fragment from another star drifted through our home. We called it Atlas. It moved faster than anything we'd ever seen, but somehow it taught us to slow down. People listen. Some close their eyes. Some imagine the comet gliding past Saturn's rings, catching glints of reflected sunlight like tiny campfires in the dark. Others picture the scientists awake at 3 a.m., watching live feeds, their faces lit by monitor glow, waiting for numbers that confirmed what their instincts already knew, that this visitor came from somewhere impossibly far away. The details vary, but the feeling remains the same: quiet belonging. Because the comet's real gift wasn't the data, it was the perspective. It showed us that the distances between stars are not barriers, just the long breaths of creation.
Matter drifts.
Systems exchange particles. The galaxy circulates itself the way a body circulates blood. Every so often a drop crosses from one vein to another, a traveler carrying ancient information, molecules older than memory. That is what 3i Atlas was, a messenger of continuity. Think about that for a moment. The same atoms now floating beyond our reach once touched light from another sun, then from ours, and someday from another yet unborn. The comet isn't ending. It's participating in the slow recycling that builds everything we will ever know. Somewhere in its dust lies nickel from dead stars, carbon from long-faded nebulae, oxygen born in stellar collapse. When those atoms finally scatter, they'll seed new worlds, maybe even skies where other eyes look up. Maybe those eyes will wonder about us the way we once wondered about them. It's humbling, isn't it? To realize that the universe doesn't forget, it just repurposes. And so the tale of the worst theory, the alien speculation that once filled comment sections, becomes oddly poetic in hindsight. It wasn't right, but it wasn't meaningless. It showed how much we want to connect, how naturally our minds reach for kinship even among comets. That yearning is another kind of science, emotional astronomy, mapping the constellations inside ourselves. As the years pass, the images of 3i Atlas begin to age like old photographs. The pixels lose sharpness, the metadata formats become outdated, archivists migrate the files to newer systems. But no matter how far technology evolves, the essence remains the same, a tiny speck against blackness, moving faster than thought. Sometimes, during quiet hours in data centers, a technician will open one of those images just to see it again. The monitor fills with that faint streak of light, and for a few seconds the room feels larger. The whir of fans sounds like wind. The blinking LEDs echo distant stars. Even surrounded by machines, they feel part of something organic, as if the data itself were breathing. That's the gentle paradox 3i Atlas left behind. In studying something lifeless, we felt more alive. The comet also reshaped how we mark time. Before, space missions measured progress in kilometers per second or years to perihelion. After Atlas, scientists began to speak in encounter intervals, the expected time between interstellar visits. It's a strange metric, one that measures patience rather than distance. The current estimate is every 10 to 15 years. A human lifetime might see half a dozen of these travelers, enough to keep curiosity alive across generations, not enough to make it ordinary. When the next one arrives, new telescopes will be ready. The Vera Rubin Observatory will catch its first flicker. Automated alerts will spread through networks in seconds. Somewhere, a child who once listened to this story will now be a graduate student receiving that alert, heart racing, whispering the same words their predecessors once said. There it is. They'll know what to do, because we practiced on Atlas. But right now, none of that future rush exists. Right now, the comet is alone in the interstellar dark, and we are here beneath our own atmosphere, surrounded by quiet. The two realities coexist like verses in a long poem, separated by space, joined by meaning. If you step outside tonight, you won't see the comet, but you might see its trail in spirit, a faint reminder that discovery doesn't always require presence. The stars above you, after all, are also messengers from the past. Their light left long before we learned to measure it. We look at what was and call it now. That's another lesson Atlas gave us. That now is flexible, that everything we observe is already history, and somehow that makes it more precious.
You can rest in that thought.
Because when you let go of needing to know everything instantly, the universe becomes kinder. Questions turn into lullabies. Curiosity becomes a form of calm. So breathe with it. Slow in, slow out. Somewhere, the same physics guiding your heartbeat keeps 3i Atlas on course. Gravity pulls at both of you, soft and steady. The same laws that move galaxies hold your atoms together.
There's no separation, only scale.
In this way, the comet never truly left. It simply became part of the rhythm that hums beneath existence. The quiet assurance that motion and rest are the same thing when viewed from far enough away. Maybe that's why stories like this belong at bedtime. They remind us that uncertainty is safe, that vastness is gentle, that science isn't a set of answers, but a way of relaxing into wonder. 3i Atlas taught us how to do that. It crossed our sky not as a warning, but as a whisper. You are part of this too. So tonight, as you lie back and the dark fills with its own kind of starlight, imagine the comet still moving, still glowing faintly against the void, carrying pieces of us into tomorrow. Imagine each rotation scattering dust that will one day become another world's sunrise. And know that somewhere, in that quiet infinity, the universe is still telling its story. And you are one of the listeners. Let the thought drift with you now. Everything that passes leaves something behind. Everything that leaves eventually returns in another form.
Even comets, even us.
Good night, traveler.